What if the words you choose in your code could make or break your program? In this video, we'll reveal how C keywords shape the language, enforce rules, and impact every line of code you write. Let's embark on a journey through the world of C keywords. We'll explore what they are, how they're categorized, the rules that govern their use, and see a real example of what happens when those rules are broken. Every programming language has its own set of rules, and C is no exception. In this topic, we'll uncover what C keywords are, why they're special, and how they form the backbone of the language. Before we dive deeper, let's clarify what a keyword is in the context of C programming. Keywords are predefined, or reserved, words in C that have special meaning to the compiler. This definition is crucial because it sets the boundaries for how we write code and interact with the language. Here's how keywords function in C, influencing both the language's syntax and the compiler's behavior. Language syntax is shaped by keywords, making them an integral part of C structure. Compiler interpretation relies on keywords to direct its actions, since these words have reserved meaning. Not all keywords in C serve the same function. In this topic, we'll break down the different categories of keywords and see how each group shapes the language in its own way. Notice how C keywords are organized into distinct categories, each serving a unique role in the language. This comparison helps us understand their specific purposes. Data type keywords include char, int, float, double, void, short, long, signed, and unsigned. These keywords define the types of data that can be used in C. Operator and utility keywords such as size of, return, goto, and typediff provide essential operations and utilities within C programs. Control flow keywords like if, else, switch, case, default, for, while, do, break, and continue manage the flow of execution in C. Storage class keywords, auto, register, static, and extern, determine how variables are stored and accessed. Type qualifiers const and volatile specify additional properties for variables, such as immutability or volatility. User-defined type keywords, struct, union, and enum allow programmers to create custom data structures. C keywords are powerful, but they come with strict rules. In this topic, we'll examine the restrictions on using keywords and why violating these rules leads to errors. Here's how the restrictions on keywords work, preventing their use as identifiers and enforcing rules through compiler errors. No identifiers means keywords cannot be used as variable, function, or struct names. Compiler enforcement ensures that an error is thrown if keywords are misused. Understanding rules is one thing, but seeing them in action makes the lesson stick. In this topic, we'll look at a real example of what happens when you try to use a keyword as a variable name in C. Here's how the C compiler responds when a keyword is used as a variable name. This example demonstrates the importance of following keyword restrictions. In this line, the keyword return is incorrectly used as a variable name, which is not allowed in C. The compiler throws an error because return is a reserved keyword and cannot be used as an identifier. The secret to writing robust C code lies in understanding and respecting its keywords. By mastering the rules and categories of C keywords, you unlock the full potential of the language and avoid costly errors.